This is our second lecture, second flipped classroom lecture if you want, on series and sequences. Series and sequences, and what I'm going to focus here are the generator, the formulas for the nth term generator, and the nth term partial sum, or the nth partial sum, in CES. Okay, so let's consider a fairly simple sequence, 1, 3, 5. And this nth term, we do have a formula for that. A sub n is a sub 1 plus n minus 1 times d. For this particular sequence, this is going to be 1 plus n minus 1 times the difference. These are going up by 2's, obviously. So I get 1 plus 2n minus 2, or cleaning it up a little bit, a sub n is equal to 2n minus 1. So I'm going to put that right here. So for these sequences of odd numbers, we can say, here's our odd number sequence, 1, 3, 5, 7, dot, dot, dot. And then instead of writing a sub n, I'm going to write the nth term generator, which is 2n minus 1. Okay, so this is a formula, if you want, formula for finding the nth odd number. Okay, if I want the fifth odd number, just put 5 right there. So the fifth odd is going to be 9. For the 20th odd number is going to be 2 times 20, which is 40, take away 1 is 39. Notice the nth odd is 2n minus 1. I can put anything in for n here. I can put in the letter k. You know, what is the kth odd number? Well, that would be 2 times whatever the number k is minus 1. Very similar to this. Right? So the kth odd number. Let's see, what comes after, see, we have the 7th odd. So that's going to be 2 times 7 minus 1. The 8th odd is going to be 2 times 8 minus 1. The kth, weird idea, the kth odd is 2 times k minus 1. What is the number that comes at k plus 1? I don't know if that's a th. That's going to be 2 times k plus 1 minus 1. Oops, I goofed this one up here. Let me back that up. The kth odd number is 2 times k minus 1, and the k plus 1th odd number is 2 times k plus 1 minus 1. Okay, and of course that can clean up a little bit. That's 2k plus 2k minus 1. Whoops. 2k plus 2 minus 1, or 2k plus 1. Okay, and that looks a little strange with the k's, but you'll see where we go with that down the road. Okay, so let's look at another arithmetic sequence. We'll pick one up. Say we have 3, 8, right, 13, 18. So the task is to find a sub n. You'll note that the common difference is 5. They go up by 5's. So this formula has to have 5n as part of it. But 5n would not be the right formula. Let's say if we had a sub n is 5n, that would say a sub 1 is 5 and a sub 2 is 10. They do go up by 5's, but they're all too big, right? These aren't 5, 10, 15. These are 3, 8, 13. So with a little bit of thought, you could say, okay, they go up by 5's, but I have to take away 2 each time. So this is my nth term generator. Now, if you want to do that shortcut, that's perfectly okay. If you really like the formula, that's okay too. A sub n, a sub 1, plus n minus 1 times d. For this particular sequence, the first term is 3. The difference is 5. So we get 3 plus 5n minus 5, or 5n minus 2. Okay, so there's our nth term generator. Okay. And so let's, again, just do a couple of interesting questions about this particular sequence. The nth term generator, if I wanted the 10th term, that would be 5 times 10 minus 2, right, which is 48. If I wanted the kth term, where k is some integer, that would be 5 times k minus 2. Now, there's not much you can do with that. You'd have to leave that alone. But if I wanted the one that came after k, say the k plus 1th term, maybe that's k plus 1st term, I don't know. That's going to be 5 times k plus 1 minus 2. And that does clean up a little bit, right? That would be 5k plus 5. Take away 2 is 5k plus 3. Suppose I wanted the one after k plus 1. That would be k plus 2. Comes after k plus 1. So the k plus 2th term would be 5 times k plus 2 minus 2, or 5k plus 10, right, don't forget to distribute, minus 2, or 5k plus 8. Okay, so there's some nth term generators. Now, in addition to the generator formula, we had our nth partial sum. Nth partial sum. So I called this little Gauss's formula. That's not really the name of it. It's the nth partial sum. And you can think of this as now a formula for adding or summing, right, the first n terms. And a quick example will sort of drive that home. Let's say we had our odd numbers, 1 plus 3 plus 5. And remember, our nth term generator there was 2n minus 1. That's what we got on the other example. Well, if I were to add these up, I'm going to get a formula, and it's always going to be n squared. And you go, okay, so where did that come from? Remember, this nth partial sum formula is just little Gauss. So if I were to take this series of odd numbers and use little Gauss on that, the nth partial sum is going to be n over 2 times the first number, which is 1, plus the last number, which now is 2n minus 1. That's our last number in the list. Okay, and I can clean that up. That's n over 2 times 2n, right, because the 1's subtract out, and then the 2's cancel, and I just get n squared. So sure enough, a formula for adding up the first n odd numbers is just n squared. Let's see how it works. I mean, if I wanted to add up the first 5 odd numbers, if I wanted 1 plus 3 plus 5 plus 7 plus 9, there's 1, 2, 3, 4. The first 5 odd numbers is going to be 5 squared. Okay, that's what this formula gives me. It's the nth partial sum. Okay, let's do another one. In fact, maybe we can go back and pick up this particular series here, or this sequence here, and find the nth partial sum formula for that. It's probably not going to be near as pretty as the one for odd numbers, but let's give it a shot. Okay, so we have 3 plus 8 plus 13 plus, now remember our nth term generator was 5n minus 2. Right? We just noted that these went up by 5s, right? Always going up by 5s, but the first one was 2 shy of 5, so 5n minus 2. Now the question is, what's this nth partial sum? So little Gauss is going to give it to us. In general, this nth partial sum is given by little Gauss's formula. I need the first one and the last one. Right, add them up and multiply by the number of pairs. So for this problem, let's see, I get n over 2. The first number is 3, and the last number is 5n minus 2. So let me try to clean that up a little bit. N over 2 times 5n plus 1. It doesn't look like it cleans up very nicely. The 2, for example, doesn't cancel here. But I could write this as, if I just multiply through here, 5n squared over 2, and then multiply there, plus n over 2. So I could write it like that, or with a common denominator, I suppose I could do 5 n squared plus n all over 2. Or I might factor it, 1/2 times 5 n squared plus n would factor is 1/2 times n times 5n plus 1. Okay, so there's a number of ways you could write it. Any one of these would be correct as the nth partial sum formula. So let me go ahead and take that last one over there, and I'm going to claim that to add these up, all I need to do is take the number 1/2. I'm going to multiply that by, what did I have, 5n? I had n, and then multiply that times 5n plus 1. 5n, was it plus? Minus 5n plus 1. Okay, so that seems like a really strange formula. You're supposed to remember that. Of course not. Let's see whether it works. I'm just going to try to add up the first 2 numbers in this series using that formula. Now, the reason I'm doing that is because obviously the first 2 numbers add up to 11. If I put 2 in here, 2 there, and 2 there, do I get 11? Now, I guess that's the question. So 1/2 times 2 times 5 times 2 plus 1. Does that really equal 11? Formula says it's supposed to. Well, let's see. 1/2 times 2, they cancel. So I have 5 times 2 is 10 plus 1 is 11. Yeah, I do. That's great. So maybe just one more check to make sure that things are on the up and up. If I add the first 3 numbers, right, so this is 11 plus 13, which is 24, this formula should give me 24 if it's the right formula. If I put 3 in there, do I get 24? Let's see. So this is my nth partial sum formula for this guy. Let's see, is 24 really equal to 1/2 times 3 times 5 times 3 plus 1? So that's the question. Well, I don't see anything really easy right off the bat. 1/2 times 3, this is 15 plus 1 is 16. Okay, so 1/2 does, right, there's a cancel here. 2 goes into 16 8 times, and 3 times 8 is 24. So yeah, it does work. Okay, so it looks like my nth partial sum formula is correct, even though it looks really ugly. Okay, so if I wanted to add up the first, 100 numbers in this list, I could just go to here. S sub 100 is going to be 1/2 times 100 times, put 100 there, so that's 500 plus 1, 501. Okay, so that's the sum of the first 100 numbers in this list. Okay, so you have a homework set tonight. It's called Homework Set 2, working with these nth term generators and the nth term partial sums. Have fun.